So first we're going to highlight what the question's asking us. That's the main conclusion from the argument above. Then we're going to scan through it and we're going to be looking with our blue highlighter for what feels more like a premise. So the first sentence, that sounds more like a sort of conclusion-y thing, maybe an intermediate conclusion. The second one, this sounds more like a premise to me. It's talking about something that's sort of a fact. Many young people don't enjoy the competitive side of sports, but there's lots of physical activities that aren't necessarily competitive. Schools should offer these. That's more of an opinion, more of a conclusion. Many people don't continue to play sport after they leave school, but physical fitness is important to maintaining general health. That's, again, more of a premise, a fact. Introducing alternative physical activities that are attractive for less competitive adults is therefore an important part of preparing students for life after school. So let's scan down these options. The one that immediately stands out to me is D, because this non-competitive word has come up twice and schools specifically are mentioned, which is what this whole paragraph is about. So the first three are more like premises of the argument. Schools have a duty to prepare students for life after school. That's nothing to do with sport, which is what a lot of this paragraph is about. Many young people don't enjoy the competitive side of sport. So what? There's more of an opinion to this paragraph than that. And many people don't continue to play sport after they leave school. Again, so what? That's more of a premise, a fact. So you should be looking at D and E. E is maybe the other one you might have considered. The answer is D, if you haven't checked already. But E is just too vague. The paragraph is really specifically talking about the responsibility of schools and about sport in schools. So when we just talk about young people and we just talk about encouraging them to find a sport they enjoy, that's not what the paragraph's getting at. It's talking specifically about the responsibility of schools and about non-competitive alternatives to help students get more into sport. Okay, time for a more mathsy question. So, we have two lights and they light up at different intervals. So what I'm going to do is visualize this for myself. It says that both of them start on, so each of these is a 1 second interval. So on the left hand side, we're going to have the one that goes off and on every second. And on the right hand side, it's on for 2 and off for 2. So it should look like that. So we've got both on, the 1 second one is off, the 2 second one is still on, off, on, off, 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 and then clearly that's just going to reset and keep going. So we have 4 seconds, every 4 seconds this pattern repeats. And neither of the lamps shines at the 4th second. So really simply, there's 60 seconds in a minute, so 60 divided by 4 means that we're going to see this pattern happen 15 times, which means that the correct answer is C. So there's 15 times in a minute, i.e. every 4 seconds of the minute, neither of the lamps is shining. Another maths one, this might be one where you wish you had your calculator with you, but what we're being asked to look at is which route has the lowest proportion of wages per kilometre of the route. So proportion of wages is just this column, per kilometre of the route, and we know that per kilometre means divided by kilometre. So that's the number we're working with. It doesn't matter that the question asks about proportion and this asks about percentage, because all of these are using the same metric. So with proportion, it's just dividing them all by 100. They still relate to each other in the same way. So we don't need to do any conversion to get the lowest proportion rather than the lowest percentage. They're the same thing when we're comparing them. So what I start with is, to me, this isn't very intuitive. So I'm just going to write each of them out as fractions. So we want the cost as percentage on the left hand side and the length on the top of the fraction. So I'm just going to do that for each of these. So as we're writing them out, what do we notice? One thing is that both of these have the same numerator. So we can easily figure out which of these is the smaller fraction, right? And it's going to be C, because 6/75 is smaller than 6/72. That should make sense. If not, just test it for yourself. If you have two numbers, if you have one number and then you increase the denominator, then that number becomes smaller. That fraction is smaller overall. So let's find our pens, and we don't want a line. Draw. And we're going to cross out this one. What else can we look at? Well, let's see if we can figure out on average sort of, well, roughly what these are. This we can change to 5/45, which gives us 1/9. So that's going to be just over 0.1. Yeah. Let's look at this one. Well, we can do 8/72, which also makes it 1/9, which is just over 0.1. So they're quite similar. And then this one, 14/56, that's about 15/60-ish, which is 0.25. So it's certainly not going to be that one. So we can cross that through. And now we're left with these. Well, let's try and figure out what this could be roughly, or let's just figure out this one first actually. 1/12, that's about 0.08, and we know that C is smaller than D. We've already crossed out D, so any fraction that is bigger than 1/12, i.e. B and E, are going to be bigger than C. Okay, so now we're just comparing each of these to our smallest known fraction that we know the value of, and we know that C is lower than that. So we're going to cross through this one and this one. So what you should have been looking for with this is what kind of quick tricks or shortcuts does it look like I might be able to do here. So noticing that these two numerators are the same, and therefore that we can sort of use these to compare against others is going to be something to look out for. Okay, Peter's clearly got too much time on his hands. He's drawn two diagrams about the cars that his parents own. So thank you, Peter, for this question. So the way that I first approached this was I just simply went through the first statement. Is the more expensive car newer? So price, car 2 is the more expensive one. Is it newer, i.e. lower in age than car 1? Yes. So I can tick that. That's a tick in case you can't tell. But then when we move on to the second one, we realise that we're not always comparing on the same chart. So here we're looking at price on chart 1 on the y-axis, but then we're looking at size on the x-axis for chart 2. So it's hard to remember, oh, which one was cheaper and then which one was bigger when you're looking at different charts. So what I did was mock up this really quick table that lets me just keep track. So the more expensive car, so we're just going to do a tick if it's the highest in each of these categories. So car 2 is the highest in price, which means that 1 is lower. Age, car 1 is higher, car 2 is lower. Speed, car 2 is higher, car 1 is lower. And for size, car 2 is bigger, and car 1 is lower. Much easier. So the cheaper car is bigger. So we're looking for the lowest price, which is 1. Is it also the largest size? No, 2 is larger in size. So our answer is B, because we're reading the question carefully and we see that it asks which is not correct. Now, in something like a maths exam, you might be tempted to go through and check that you find these are also true, so that you're also double checking by process of elimination. But take the win here. Like, if it's not taken you 2 minutes to do the question, if you can claw back some time, because when I did this, I basically ran out of time. I had to just guess on the last 3 questions when I originally sat my TSA. So if you can claw back time on this, I think our strategy is pretty foolproof. We've realised B is the correct answer. Don't check it. Just go to the next one. This time we're again being asked to draw what we can draw as a conclusion from the passage above. I found this one of the trickier word questions on this paper. So let's go through as a process of elimination maybe. So A, this is kind of a hypothetical tone and it's quite sciencey. I mean, the whole paragraph's quite sciencey, but they're asking you to draw sort of a scientific conclusion from a few sentences you've just read about one specific case. So to me, it didn't feel like A was the right one. The benefits of natural flood management schemes go beyond reducing flood risk. That one only comes up explicitly in the final sentence, but when you actually read through this, so with saving, in fact no, sorry, that's a silly thing to highlight. Let me get my highlighter out and then I'll get my head on straight. So we slow the question is, does natural flood management do things beyond reducing flood risk? We've got restoration of heather moorland. That's maybe a good thing in and of itself, and the planting of thousands of trees, even though it's acting as a sponge. Around half the reduction of floodwater in the town was due to upstream land management and half due to the effect of the flood storage area. And then natural flood management measures improve water quality, prevent erosion, and in some cases store carbon. So these 2 sentences sort of point towards this. So I'll tell you now, the answer is B, but for me, I had to still keep going through the rest of these options and satisfy myself that they were worse options than B. Because remember, we're just picking the best fit. You might think none of them are perfect fits. So let's go on to C. All natural flood management methods are equally effective in reducing river flow. That's really strong, and it doesn't say anything in this paragraph about that. And also you'd be drawing a really strong conclusion just from one case study. So we don't like that. That's bad logicking. D, natural flood management should be introduced in all areas at risk of flooding. Maybe that's something that you think from having read this, but that's not an argument that this paragraph is making. So that's a no. And natural flood management methods are most effective in hilly upland areas. It doesn't say that anywhere here. And again, if you're talking about most effective, then you'd probably want to be comparing a hilly upland area and a non-hilly upland area. It's just weird to conclude something about the effectiveness of natural flood management methods just from one case study. So we end up with B. It's not the best fit. Well, it is the best fit. It's not the most obvious of conclusions. You could probably write one yourself that felt a bit more natural. But when we look at the rest of these, they are not really they're drawing too much from just one simple case, whereas this one is more nuanced. Okay, now remember, we're always reading the question first so that we don't waste our time reading through this thinking we're looking for the conclusion when actually we're looking for the underlying assumption. So, the impact on people's pockets is more important than the need to control carbon emissions. I would say that is an assumption of this passage, so we quite like this one. Let's just do a little arrow by it for now. The cost of fuel is too high and must be reduced. That's really explicit in this paragraph. That's not an underlying assumption. They've said that there's crippling price rises. That's quite gives a sense of their opinion that it's too high and that it has to be reduced, because that's their final conclusion. So we don't like that because it's not an underlying assumption, it's an explicit premise of this argument. The only justification for higher fuel taxes is to reduce carbon emissions. That's actually sort of the opposite of what this paragraph is saying. This paragraph is saying it's not sufficient justification because they want the government to reduce fuel taxes even though increasing them might help reduce carbon emissions. So we don't like this one. Road transport companies could go out of business if fuel tax is increased. Maybe that's something you could investigate based on this. Maybe it's a sensible next step, but it is not an assumption of this passage. We don't need to specifically know that road transport companies will go out of business to get our conclusion that the government must abandon its planned tax increase, because we're also talking about UK households and shop goods, so not an underlying assumption. E, the government could use its increased levels of North Sea oil revenue to reduce fuel taxes. If this one were true, then it means that they've missed out a really key premise in the argument, because they've said that there's extra revenue coming from North Sea oil reserves, but they've not said that that money needs to be used in order to reduce fuel taxes. It's not necessary that revenue needs to be found from this to reduce fuel taxes. It could come from other places, but maybe, I mean, it's certainly better than B, C, and D. So if you were stuck between A and E, or if your initial thought was to go with E rather than A, one way that we can sort of test this is to try inserting them into the paragraph as a negative. So if we said the impact on people's pockets is less important than the need to control carbon emissions, if we stuck that in here, then the conclusion doesn't make any sense, because you're saying that controlling carbon emissions is less important than the amount of money that households have, but your whole argument is that households can't afford for this increase and that it's not worth it based on just the fact that it will reduce carbon emissions. So that makes us think A. And then if we try that same approach with E, the government could not use its increased levels of North Sea oil revenue to reduce fuel taxes. The argument doesn't fall apart. It's weird that you then put this line in about North Sea oil reserves, but there's other ways that you can reduce fuel taxes. It doesn't rely entirely on being able to redirect that North Sea oil revenue. So hopefully that makes it clear why A is our answer here. Now this is a fun one, we haven't had this yet. Which of the following, if true, most weakens the reasoning above? So the whole premise of this argument is finding and committing, basically getting married, is well worth pursuing as a goal, because all these amazing things are more common for married couples than for people who aren't married. So I'll tell you now, the answer is E. And the reason why is, what this article is saying is we have this thing, oh, not a Z, a Y. We have this thing X, which is getting married, which leads to, directly to Y, this suite of really great things that include being happier and living longer and being wealthier, etc. But there's actually something in between, okay, another variable that is causing both X and Y. So this arrow doesn't actually exist, okay, and this arrow is causal. So there's actually no causal connection, probably, between being married and having all these great outcomes. Instead, there's a separate variable, which is being wealthy, which means you're more likely to get married and you're more likely to have all these good things happen to you, including being happier, living longer, and also being wealthier. If you're wealthier, you're more likely to be wealthy. So that's why E, if it's true, most weakens the above reasoning, because it means we have this third variable which is causing both of these rather than the causal relationship between marriage and wealth. But let's quickly scan through the other four in case you got tripped up on any of them. Research suggests that being married boosts the chances of surviving cancer. This is just another great thing about being married, so it seems to fit right at home as another premise in this paragraph, so we can cancel that out because it doesn't weaken the reasoning. Statistics on marriage don't differentiate between those who have children and those who don't. Well, that might be true, but the statistics on marriage are still favourable, more favourable for people who are married than for people who aren't married. It's irrelevant whether you're differentiating between people who have children and don't, because the overall effect, which is what this paragraph is summarising, even when you don't differentiate, it's still more positive for married people than single people. In many countries, being married gives advantages in terms of tax payments. Again, that's just another good thing about being married. What you might think is, okay, maybe there's a way, if you're married, i.e. X, then you get your tax payments, let's call that, what should we call it? Let's call it C. And then that means that you're wealthier and you're happier and you live longer because you're paying less tax. But X still leads to Y, even though there's this X causes C, which in turn causes Y, it's still X which is setting off this causal process. So that would still support this argument. And then lastly, individuals in conflict-ridden relationships are more prone to illness than happy couples. Not relevant. It's sort of like this one with children, because this paragraph just takes married couples as a whole. It doesn't differentiate between different types of married couples, like those that are happily married and those that are unhappily married. Overall, the effect is still more positive for being married. So that does not weaken the argument. There we go. 3 friends are training to run a marathon. So the first one, A, takes 3 minutes. Second one, B, takes 5 minutes. And the third one, C, takes 6 minutes. And we want to know, if they each maintain their running speed throughout the session, how many more laps will A have completed compared to B when they next cross the start line together? So we want to know, at what time do all 3 of them cross the start line at the same time, given these different times it takes for them to complete their laps. So it's pretty straightforward maths. We just need the lowest multiple of these 3 numbers to see when these 3 will meet again. Sorry, went a bit Macbeth there. So 3 goes into 6. We don't need to worry about finding a multiple for 3, so let's just find one that 5 and 6 go into. it's pretty simple. 30 is the lowest common multiple of these three numbers. So we know after 30 minutes they'll all cross the start line together. But what we're asked to do is to see how many more laps will A have completed than B. So in 30 minutes, let me get back in, A has completed 30 divided by 3, 10 laps, and in 30 minutes, B has completed 30 divided by 5, which is 6 laps. How many more laps will A have done than B? It's 10 minus 6, and the answer is 4, which gives us B. Don't panic, we can do this. There's a list of a lot of questions, but let's make it as simple as possible for ourselves. So let's look at the options. We know we're comparing year 1 to year 3, we're reading the question carefully, so let's just get rid of this column. Don't need it distracting us. Now, we're multiple choice because Oxford wants us to succeed. So the lowest option is 50%, and we're looking for the biggest percentage increase. So any that we know that the smallest possible answer is going to be 50%. So any that are lower than a 50% increase, if they're 30%, 40%, we can cross them through. They are not the country that we're looking for. They're not the answer we're looking for. So a 50% increase is going to mean for 52, you'd be halving it and then adding that on. So you can do it really roughly. Add 25, that gives you 75, 65 is less than that, so we're crossing that through. Veranda, half of 60 is 30, that gives us 90, so it's less than 50%. Carbonda, now we should know that this is the percentage increase from 20 to 40, it's doubled, so it's a 100% increase. And let's just make that really clear. Carbonda is a 100% increase. So now the goalposts have moved. Now we know it's not 50%, it's not 75%, so we're looking for anything that is above 100%. So either 150% or 200%. So let's keep going. Albonia, it's less than double, so we cross through. Freponia, less than double, cross through. Grandia, that is definitely more than double, and because it's triple the amount, 20 times 3, that means it's a 200% increase, because you do the new number minus the old number. Let's type this out. The new number minus the old number divided by the old number, which gives us 40 divided by 20, which then gives us 2, but we then times that by 100%, which gives us 200%. So our country is Grandia, the increase is 200%, that's the biggest one, there's no bigger option, so we know that it's E. So we don't even need to look at the rest of this table. See, things are never as bad as they look. They want to help you and it'll be fine. Okay, last one for this session. It's our last mathsy-ish one in a row. So I'm just going to walk you through which side is which. So A, we're looking at it, let's do a darker colour. A, we're looking at it from this side. Is that clear? It's hard to make this 3D. A, we're looking at it from that side. B, we're looking at it from the back. B. C, we're looking at it from underneath. So it's sort of been flipped and we're looking at it from down here. Now, how is a girl to represent that? Let's put that there. And then D, we're coming from this side. It's just A, but from the other side. So E is incorrect. Maybe what you think is that it's trying to look from above, and I think that would be correct if it weren't for this line here, because that would mean that this has to be closed off either here or at this level, this middle level here, or at the bottom level. And you can see it's not, because there are no lines crossing this sort of chimney section other than this one, which we know is at the top of the shape because you follow it round and you can see it's part of the open top. So that's why E is not a possible view, because this chimney has been closed off at the back.